Hello everyone, this is Karthik Kumar Joshi and I am going to understand you the power system protection. This is our third relay name as induction cup relay. We earlier explained that two relay, one is induction disk relay, second one is attractor armature relay, third one is induction cup relay. So let's focus on the diagram that what it clear that there are two type of input. What are the two type of input? First one is voltage and second one is current. So now we understand that how that two input is carries out to the induction cup relay. So here we are going to focus that how they are going that two input. Let's consider that this is transmission line. In transmission line current is flowing. We connect one CT in series with the transmission line because the CT name as current transformer and current will remain constant in series, so we attach it in series. But what about PT? PT means potential transformer, so we attach that potential transformer, that means in parallel. Why parallel? Because if we want to calculate or if we want to measure the voltage, we have to attach our voltage meter or potential transformer in parallel. That means this is the PT and this is the CT. So what happen in CT? CT means current transformer and it transform the current, that means step down current. And PT will potential transformer, so it step down the voltage. Now we are focusing on the induction cup relay diagram. In induction cup relay there are 5 names, 1, 2, 3, 4 and 5. So one by one we can understand that what is one is backstop, second one is moving contact, third one is fixed contact, fourth one is a rotating cup and fifth one is core. So how it is rotate, we can say that if our moving contact is rotate in clockwise direction and if that moving contact is strike with fixed contact, that means 3, our circuit breaker is open and fault will be clear. There is no chance to rotate our moving contact in anti-clockwise direction because there is one backstop there and it not allowed to rotate our moving contact in anti-clockwise direction. So we have only two chances. That what are two chances? Voltage and current both are positive or voltage and current both are negative, then our moving contact will rotate in clockwise direction. So as we discussed, there's one is a backstop, 2 is a moving coil, third one is fixed coil, fourth one is core and fifth one is moving cup. This is the vector diagram of induction cup relay. This is the voltage and this is the current. The angle between voltage and current is phi, so the flux is created is same as the current direction and voltage flux is created in PT is 90 degree to 8. So we can say that the angle between phi I and phi V is alpha and angle between voltage and current is phi. So here we are going to calculate the torque developed in the induction cup relay. This is the equation of torque developed in the induction cup relay, where torque is dependent upon the 3 parameter phi V, phi I and sin alpha. That is direct proportionality. So phi V means the flux developed in PT, phi I means the current developed in CT and sin alpha is the angle between two fluxes. So here we are going to convert that sin alpha into cos phi. That means we know that sin 90 minus alpha is cos phi. So it is our final equation that torque is dependent upon the flux of voltage phi V, phi I and cos alpha. That means If the voltage and current both are positive or voltage and current both are negative, our moving contact will always rotate in clockwise direction and strike with fixed contact and circuit breaker is open. And third one is cos alpha. As we know that when cos is positive, that is in quadrant 1 and quadrant 4. That means we know the rule that all STC, that means cos alpha is remain positive in 0 degree to 90 degree and 270 degree to 360 degree. Then and then cos phi is positive and torque is positive and our moving contact is rotating clockwise direction and fault is clear. So it is understand here that we discuss. This is a graph where our induction cup relay is working. That we know that this is first quadrant, second quadrant, third quadrant and fourth quadrant. In second and third quadrant, the cos value is negative, that means torque is negative, so this part is known as blocking region. The value of cos is only positive in first quadrant and fourth quadrant, so it is known as stripping part. But here is some part. What is this? So it is known as a polarization voltage. It is known as a polarization voltage. What is polarization voltage? The minimum voltage required to operate our induction cup relay is known as a polarization voltage. It is very necessary because if the current is there but voltage is not there, the multiplication of both two are becomes 0. That means voltage is 0 and current, let's assume that 5000, but 0 into 5000 is 0. So there are requirement of voltage also, because we give two input, voltage and current. So there are requirement of voltage also, and the minimum value of voltage that required to operate our induction cup relay is known as the polarization voltage. So above polarization voltage, our induction cup relay is work. That means in between or below the polarization voltage, our induction cup relay is not work. That means it part is known as a dead zone. So this part is known as dead zone. Above that voltage tripping and below that voltage is blocking. As we explain and as we understand, this is right here. So thank you everyone for your time and for your attention.